And we're ready to go. Okay, I'm going to differentiate this. Now, e's are different. E's are different. Before, we had things to the power 3 or 4 or 5 or something like that. It didn't really matter what was in there too much. But e's are different. E's are different. And if you look at your formula sheet, you will find there's all sorts of different things that happen with depending what your starting function is. If you look at your formula sheet, it will tell you that if f of x is e to the x, then the derivative of f of x is also e to the x. It does not change. So if I'm over here doing my derivative again of this, of my e to the x squared plus 3, it doesn't change. You get e to the x squared plus 3. It's a very unusual, particular function, the e to the x function. But just like before, we had to multiply by the derivative of the inside part. This time, we have to multiply by the derivative of what was in that bracket there, the power part. So this will give us e to the x squared plus 3 times 2x. And we would normally write that as 2x e to the x squared plus 3. Let me give you another one. So the rule for e's is that they stay the same, but you still have to use that same process of multiplying by the derivative of the bracket bit. So if I do another one, if this time I started with my function was e to the power x cubed minus 3x, then the derivative, well, e's stay the same, so you just write the same. But you have to multiply by the derivative of all that top part, which will be, and I'll put it in brackets because there's 2 bits, 3x squared minus 3, which should be 3x squared minus 3 e to the x squared minus 3x. You can see they get kind of long and involved. And this part, I'm going to put it in brackets because it's this, so a whole lot times that, not just the one little part of it. You might also, because you can see the 3's there, you could factor them out if you want. You get 3 into x squared minus 1 e to the x squared minus 3x. One more, and then I'll let you get going, and we'll see see how you go with it. So this time, I might put some fractions or something. I'll make something kind of ugly. Here we go. This time I'm going to start with my function is equal to e to the negative x squared plus 3x. The derivative of that is equal to, it stays the same, e to the negative x squared plus 3x. But we have to multiply by the derivative of all the power part, put it in brackets, it'll be negative 2x plus 3. There's not much simplifying I can do with that, so I'll just write that as negative 2x plus 3. Got to be in brackets because it's all that times the other part. Negative x squared plus 3x. Okay, I think you can. I'll stop that.